All right. Welcome to section 1.7, where we're going to talk about inverse functions. So before we talk about inverse functions, let's just remind ourselves about what a function was. Okay, a function is a rule assigning to each x one single y. Okay, so that took the form of what we normally or colloquially call the vertical line test. Okay, so now a function is invertible if we can assign to each y one single x value. Okay, so what I want you to notice is that the y and the x have switched places. Okay, so what that means is that we're going to have a new rule, colloquially you can call it the horizontal line test. Okay, so now let's take an example. We're going to take my favorite example, of course. Y equals x squared. Okay. Y equals x squared. Now, this is a bad example because, as you can see, it fails the horizontal line test. Therefore, it is not invertible. Well, you might ask, well, Dr. R, why on earth would you give us an example that doesn't work? Well, because we can play around with it to make it work. Because I really like y equals x squared. I mean, I like it a lot. So I'm gonna make it work. Let me draw another coordinate axes. Okay. And I'm gonna write y equals x squared. But now I'm going to restrict my x values to be greater than or equal to 0. So now, if I draw the graph, this does pass the horizontal line test. Okay, this does pass the horizontal line test. This is invertible. And it has inverse. I'll explain how to get it in a minute. The inverse is y equals square root of x. Okay, now I could have done it another way, and why not? I could have restricted it over here. Okay, I could have said y equals x squared with x less than or equal to 0. Okay, and then that's still invertible. Okay. And now it has inverse y equals negative square root of x. Okay, let's show you guys how to do this, how to find inverses. Okay, now my steps towards finding inverses algebraically are a little different than the sort of usual steps you'll see, but they still work, okay? So just keep that in mind if you go to YouTube or go somewhere else to find another take on this. You're gonna see something a little bit different than what I'm presenting here, okay? The first thing that I'm gonna say is, let's say you have your given y equals f of x, okay? First thing I'm going to do is, can you solve for x uniquely? I think I misspelled unique there. Okay. And when I say can you solve, I don't mean you personally. I mean, is it possible? Okay. I know a lot of students will be like, can you? No, I'm done. Yay. That's not how we're going to work here. Okay. Finally, you're going to make a replacement. You're going to take y and change it to x, and x and change it to f inverse of x. Okay, so this is the process. All right, so let's start with y equals x squared. Okay, so now we're doing the example that doesn't work. So right on first step, or actually the second step, B, when I try to solve to get y by itself, I'm going to get y equals, I'm going to get plus or minus square root of y equals x. Okay, so you see that this plus or minus is a problem. I cannot solve for x uniquely. There's these two values that come out. Okay, so the plus or minus gives me a problem. So this is not invertible. Okay, let's take a look at case 2. So our second case we took y equals x squared. X is strictly greater than or equal to 0. I don't need to say greater. I don't need to say strictly. It's greater than or equal to 0. Okay, so now when I take the square root of both sides, I get the square root of y equals x. I don't need the minus. In fact, I don't have the minus because my x is strictly greater than or equal to 0. Okay, so this gives you the greater than or equal to part. And now I can go to part C. So replace y with x, and that then gives you f inverse of x. So f inverse of x equals square root of x. Let's look at case 3. All right, case 3 was y equals x squared with x being less than or equal to 0. Okay, now when I go and take the square root, remember x has to be less than or equal to 0. Square root of y equals x. I'm missing the negative sign, okay, because the square root always gives me something positive. All right, so we're going to have a negative sign there. And now, making our replacement, f inverse of x should equal negative square root of x. Okay, one more thing I want to point out. is these graphs. Okay, so in case 2, okay, we have x being greater than or equal to 0. Now, the inverse is the square root of x, looks like so. And what I want us to notice is that it's effectively a reflection across that line. Okay, let's do the same thing with this second case. Y equals x squared. Here, x is less than or equal to 0. Looks like so. Why do I always do that? Okay, now f inverse of x is the negative square root of x. Okay, so it's like so. It's still a reflection across this line. Okay, so another way to think about this is actually something it's not part of the definition, but it's extra. Where's this? Let's go to, now let's just write it down here. Inverse function is a reflection across the line y equals x. Okay, all right, I'll see you all in the next video.